So what do we want to talk about? We want to talk about Ethernet-APL, a little bit advancing process automation for the digital age. And what we want to do is we want to look a little bit into history and then to see, okay, what are the requirements of the process automation today and how can Ethernet-APL actually fulfill these kind of requirements? And then we want to also see, okay, how do we fit as Softing into the picture? What do we do with that? And then we are open for questions. We probably have 22 minutes, so we're not going into all the detailed stuff like that, but then we will have also follow-up webinars where we talk about more in detail about other topics. So first of all, what's the status quo of process automation? So I stole this slide from the Ethernet-APL, Ethernet to the field. And I think what's interesting is to look a little bit, if you look at the technology, leave the pneumatic out of the scope at the moment. And if you look at what's happening in the process automation industry, and I compare this to the telecom world, where I used to work 20 years ago, the telecom world, we had backplane technology, and we had bus technology, parallel buses, and then we moved to Ethernet. We moved to 100 megabit, then we moved to 1 gigabit, then we moved to 10 gigabit. So it was a constant incline of the technologies. If you look at the technology we have in the process automation, there's 420 milliamps, then there's the same with hard on top, 1.2 kilobaud on top. Then we have Fieldbus technologies, which is mainly PROFIBUS PA and foundation Fieldbus. But what's interesting is that's not something that evolved step by step and then goes to Ethernet. It's actually, most of the part is still on 420 milliamp. So it's not like it was in the telecom industry that has moved already to a kind of Fieldbus technology and then over to Ethernet. So we have 3 different starting points where we have to go to Ethernet to. That's one part of it. So one reason is we want to have the speed, we want to have the digital signals. The other thing is what we are seeing today is even with the Fieldbus, we still require a gateway. And one of the reasons why the Fieldbus technology and PROFIBUS PA was a little bit tricky to introduce was that makes things much more complicated. Because at the end of the day, if you have that, you have still a different network topology, you have different speeds, you have to adjust to that. That makes it more complicated. So you need experts in this case for Ethernet Profinet, but also experts in the PROFIBUS PA. And what we want to achieve is Ethernet is really seamlessly from top to the bottom, that really everything is integrated. So if you look at digital today, and we look at an example, Softing, for example, just as a topology, we have engineering tools there based on Ethernet, there are plant asset management tools, there's industrial switch. These switches are pretty fancy managed switches with VLAN and different things like they can offer. So a lot of opportunities in there, also like firewalls. Then you have, for example, PLCs, some Profinet devices, and we are talking mainly about Profinet today. Why? Because Profinet is the higher level protocol technology that's implemented on Ethernet-APL first. Then we have a gateway, and then we have Profibus, in this case, behind that. So what we have today, we have an PN gate PA. The nomenclature is in Softing is PN is the north side, as we call it. PN stands for Profinet, gate stands for gateway. This is mainly a proxy, so it's a higher functionality than gateway, but in general, it's like a gateway. And PA is the south side, so we're talking Profibus down there. So with this technology, to make this intrinsically safe, you need additional components as well, like power conditioner, field barriers, and junction boxes. So that's what I would say, that's the digital reality today in process automation. As I said before, you still have this break between different kinds of technologies. So if you look at the requirements of the process industry, I mean, what we have, we need high-speed data rates. That is for 2 reasons. One reason is really that you can parameterize the devices very quickly. That's one reason. The other reason is we want to get the data out of the field because there are more and more sensors, there's more and more information, more complex information, not only temperature and flow, but also different kinds of information that you want to have in your central database. So one requirement is high-speed data rates. The second one is it should be future-proof. So I said, because I mean, this plant should be alive for 20, 30 years. And I had one customer at the SPS that was only last year coming to my place. He was talking about his plant. He was very proud of it. It was a PROFIBUS PA plant. Then I said, okay, then why are you interested in Ethernet-APL? And he said the only reason why he's interested after introducing all these things is that he is a little bit scared that in the future, PROFIBUS PA won't be the focus of the field device manufacturers, because the people he talks to, they say, no, we're investing APL because that gives us much more headroom. And they'll probably push PROFIBUS PA a little bit behind. So the requirement is really clear. We need a future-proof network infrastructure for the next 20, 30 years. Long ranges, sometimes we have quite some distances in some plants. Extensive diagnostic capabilities on field device level, but also in the switch. I want to know what's happening in the switch. What about the temperature, humidity? Is there any possibility that something fails? Also, as I mentioned before, seamless integration to make the whole usage much easier. And an additional point that comes up now that we get Ethernet into the field is also cybersecurity. So we're not touching on this point in here. There's not enough time, but there will be follow-up things where we also talk about cybersecurity, since we are already certified as a company from a process level on the IEC 62443. But that will be an additional topic in a follow-up webinar. So what's now the path to Ethernet into the field? So if you look at Ethernet-APL to get you all on the same level, what is it? It's a physical layer. So we only talking the first layer, like an Ethernet cable would be also the physical layer. It's a 2-wire cable, data transmission power supply in one. Length up to 1,000 meters, explained later in the topology where the 1,000 meters are. It's intrinsically safe, it's suitable for hazardous environments, also for X. Provides fast Ethernet communication at 10 megabits per second. And as I mentioned before, integrates seamlessly. There's a nice picture that I like because that puts it all together. Here you have the two wires, 2-wire cable. They have the speed, you have power over the cable, and X safe. And important, this picture is what's on top. Like today we're talking about Profinet. In the future we might talk about Ethernet IP as well. That's protocol independent. That means these higher level protocols are independent of what's below. So technical attributes, that's more to read it up. The only thing what I want to mention here, all this stuff is actually based on existing technology and existing standards. So for example, it's 10 base T1L, the 10 megabit stuff. It's the IEEE organization. Then we have the IEC 61158 for the cable types, and all that comes together that we have a network with 10 megabits per second, full duplex with 31 kilobits PROFIBUS PA, if you want to compare to PROFIBUS PA. So what I want to say, the main message is that that's really based on standards. It's not inventing something from scratch, it's really based on standards. Speed comparison, just quickly, again, we are here on the level 1. That means just how the bits run from the left to the right side. And if you compare this hard with 1.2 kilobits per second, Profibus with 31 kilobits per second, by the way, this is exactly the same the same rate I had with my first modem in the middle of the 90s. And this one is then Ethernet-APL, which is 300 times faster. And this 10,000 times faster sounds very fast, but if you go to the higher level protocols, you have some frames, you have to put some stuff in this. So in general, you can expect between hard and Ethernet-APL probably a factor from 30 to 70, depending on the application that's running on there. But that means in terms of parameterization, the difference between 10 minutes and 10 seconds. So that's really a big difference in speed. So Ethernet-APL has that 3 different kinds of switches from a network structure perspective. You have the industrial Ethernet here, the green one, 100 megabits, 4-wire technology. And usually the devices and switches need auxiliary power. In this term, the switch here gets the power from there. Ethernet-APL, 10 megabits reduced data rate, the 2 wires. And the switches can, but they don't have to, get the power via the communication line as well as the devices. So the first thing that gets actually implemented is this technology. So the field switches, power in there, power comes in here. You have here the connectivity to the north. That's this one here. On top is can be a cable, like a typical Ethernet cable would be copper, would be 100 meters. If you have a longer distance, for this one here, 2 to 3 kilometers would be the fiber channel. And here the spurs we're talking about actually to the south are 200 meters. And another technology that's probably coming in the future is this one here. So you have a power switch. All it does, it translates the power, the external power into internal power, runs it over the cable, and that's where you're going to find the 1000 meters. And here you have a APL field switch who gets the power over the trunk table. The disadvantage with this one is here we're already having only 10 megabits per second. So it means if you have 10 megabits here, all the 8 to 24 or 16 spurs have also 10 megabits. That might be a little bit challenging in the future. So use case brownfield is a little bit what we did is we used our PNGate PA technology that we've been using for 10, 15 years already and pushed it in the APL switch field. So this gives the opportunity to use PROFIBUS PA, but in addition also Ethernet-APL devices. So from a migration perspective, that's a very good way. If you have existing PROFIBUS components, you can reuse them, and for new stuff, you can use Ethernet-APL. So it's a nice way to migrate from a PROFIBUS PA perspective to Ethernet-APL step by step. Another thing that we'll also figure out here, you don't need, for intrinsically safe, you don't need the barriers any longer. That's a point-to-point connection from here. And also what we also do as software, we do something like co-modules APLs. So we're not only interested in the switch technology, we also look at the field devices, and our take is there, we have a hardware and a software. The idea is to help field device manufacturers to implement APL technology very quickly. So they do all the measurements and all the other things. They can use whatever they used before, and we help them by doing the interfacing on an electrical and a software level between APL and the existing technology. And CNIC is a good example. We showed this also on the ACHEMA. So when you open this element here, you can see there's the hardware in there. This hardware does all the APL interfacing, and the customer does only the stuff internal what they already have. So that allows also to get to new field devices very quickly, especially if it's more like a niche market. We are not talking about a temperature like that. The switch itself, field switch with industrial Ethernet, redundant power supply, all the different ATEX certification for the X Zone 2. 16 spur ports that you can see here. This PROFIBUS PA device support, as I mentioned before, you can mix between APL and Profibus. Profinet enabled MRP is for redundancy issues, conformance class B, detailed diagnostics, as I mentioned before, and also an FDI package. So that FDI package is mainly used by asset management systems if they don't want to use the web browser for that. Integrated web server, and we also have a local display. We talk about this in a second. And really the idea is to get connected to Ethernet-APL very quickly. So if you look at the web page, I mean, you have the different kinds of trunks. That's the North stuff. You have here the spurs, the 16 spurs. And here you can see in this example is a mixture. Here, for example, on spur 2, you can see that's a link with 10 megabit per second. So that's really Ethernet-APL. You also see physical values, signal noise ratio with the 37 dB. You can also see from a power perspective, it has the .553, which is power class A. Below, it's PROFIBUS PA. You can see here it's a little bit less in terms of the performance, but that's a mixture of APL here, APL there, and Profibus. What you also have, then you have redundant power supply. You can check that everything is the right scene in terms of this traffic light, things like that. So that's the web server stuff. The other thing, what we also have on the switch, what we implemented, especially for configuration, but also for some other topics, is LEDs. You know that also from other things, but that's really a small display there. It's only read-only, so you can't access this internally. You can't change anything, but you can read what's with the trunks, what's with the spurs, how many spurs are used. Interesting, when we were at the trade fair, we had a problem with the power supply, and we could see it without even looking at the web interface. You can also see it here on the local display. And the other thing, what we also see is, for example, later in the field is sometimes you have external service personnel. Probably you don't give them access to PCs, to access your Ethernet network. So the basic stuff they can see directly here on the switch. So how does greenfield look like? I mean, greenfield is the same, but without the proxy functionality. Then we also talk only Ethernet-APL. And that will be then the first time that we really have seamless Ethernet down to the field devices. We are very excited about, because that really means now it's really completely Ethernet infrastructure in there. So here Ethernet-APL. So here Profinet runs over the switch and over the devices here. So the second one, I'm also just show you the difference is there's no PL proxy involved. So it's also a little bit cheaper, and it has on the 16 spare parts we have 12 class A, which is a .553 watts. But we also got requests already 1.5 years ago from field device manufacturers who said, okay, now I have more complex field devices, and for these complex field devices, I need more power. So we integrated also class B, which is 1.17 watts, intrinsically safe. So that gives a lot of headroom for field device manufacturers also to add field devices that need a little bit more power. So two versions of the switch, one with PA functionality, one without. So what's also very important is for the whole ecosystem, you have to validate it with the most important systems. So we have on a DCS level, we have Siemens, Emerson, ABB, we do our testing with, and also the stress testing with that. That's on the DCS side and under Profinet, but also on the asset management system side, because we also have technology to give this data directly to the asset management system. So we also want to support this, of course. So it's, for example, PDM, the AMS device manager from Emerson, ABB FIM, and we are working on some others as well. But these are probably the main ones. From a control perspective, Siemens, Emerson, ABB, and from an AMS perspective, also the same three. So if you look at the ecosystem, what really impressed me, it looks like there's everybody behind that. These are end users and operators. They really see the need for that. We have the control system suppliers also supporting that technology, the EPC, so the planning folks and all the system integrators, which work very closely with the end users and the operators. The field device manufacturers are behind that. And I don't know who of you went to the SPS or the Arkema. You could see already a lot of different manufacturers, not only the blue ones here, supporting Ethernet-APL. And this is important that this ecosystem really works. And the other thing is infrastructure manufacturers. So if you talk about switches, would be classically infrastructure. There are also the choice for different switches. There's choice for different field devices. And there's the choice of also using PROFIBUS PA in a kind of migration step. So we think the market is really ripe to go ahead with that. And that's something I stole from Namur. It's in English. So so they really say Ethernet-APL, which is the physical layer, and we are a Profinet company, the technology on stock that's ready to go. So it's ready, it's tested, devices are available, more to come in short time. So even roadmaps of suppliers for 2025. And there also is a strong community behind this to adopt this technology. And the question is really, are you ready to go that step? So we are ready with that. So the final release, we are doing additional stress testing with the different devices we have. We do long distance testing at the moment. We really look, is it more than 200 meters we can fulfill all the time to make sure that at the end of the day, you get a really finalized X-safe product. And that will be the end of January 2025. As a kind of a summary, what do we see? Integration into DCS. So the commitment from the control folks is there. We have very extensive diagnostic, web server, FDI for AMS and the local display that I showed before. Integration into AMS. I show a picture about this one on the next slide. We have tried to get rid of the additional gateway hardware, so that's not needed any longer, which is a nice migration way, and it makes the commissioning and maintenance quite easy. So if you look at softening just where we are, we have the switch here in the middle. The south part I explained already, what we do in terms of working with field device manufacturers, supporting them. But we also have some technology to give you very easy access to plant asset management systems. So for us, it's important not only to be a switch vendor, but also to understand what's happening at field device level and also what's happening on Profinet on this level, and how can we really add value to the end customers. Because the end customers are really interested in plant asset management, having access here seamlessly into these devices, seeing what happens with these kind of devices as an additional benefit. So what we do is here, this one is more what we call a competence, because it's only for a few customers where we work very closely with them. And on top is then what we really help in terms of plant asset management. So this one here on the bottom part is really what we see as customer specific, and the top part is really what we have of products on a software and a hardware level. So we offer the software and the hardware as well. So that should be it. I think it was 21 minutes. So that was really in a nutshell the Ethernet-APL technology, and I'm happy to get some questions from your side.
We got one from Mohsen Habibi. Is the PA proxy available on the other application layers such as Modbus TCP APL or Ethernet IP APL?
It's available on, so this one is, you mean inside the switch? So we have gateway functions in this case, it's Profinode to PA included in the switch. What's not included in the switch is, for example, Ethernet IP to Profibus PA. That's not included in the switch.
Mm-hmm. And then the question was also about whether it includes Modbus TCP APL.
No.
Next question from Václav Koctiek. Do you plan to support Ethernet IP networks? When will this option be available?
Yeah, that's an interesting question. The tricky part is, as I mentioned before, we saw the ecosystem. So the tricky part is we need the field device manufacturers to support that. Most of them have, I think there are now 18 to 20 Ethernet-APL sensor devices and 1 or 2 actors available. They're all based on Profinet. So they're not based on Ethernet IP. My personal feeling was a little bit when I talked to people in the US that they're more a little bit in a kind of a waiting mood. So we're happy to get different signals about this one. So at the end of the day, what you need for that is you need the support also on the field device level. I mean, if you look at Ethernet IP, for us, from a switch perspective, that would work instantly because this switch is just on level 2. So the switch itself doesn't really care what goes in, what goes out. He's just a transporting medium. So at the end of the day, you could say we already support Ethernet IP on the switch level, but that is something that the field devices need to support as well. So and I assume that will probably start in 2025. I haven't seen, I'm happy to get some feedback on that. I haven't seen a lot of field device vendors to support this. My feeling was a little bit, okay, Profinet, they start with the Profinet stuff, they see how to make this successful. And I have to say that Amur is doing a very good job to push that. There are already a couple of plans already, not only on the lab level, but also on really production level that they're building up. So that looks really like, for this new technology, the ramp up looks actually pretty good. But that's all based on Profinet so far. So I'm happy to get requirements regarding Ethernet IP. I got a few of them, but not that many so far. And yeah, and what you see in the field is, I mean, from a switch perspective, I can support that, but what's missing is then the field device things, and I'm not quite sure at the moment. At least I only know one company who is going to support Ethernet IP in the next 6 months.
I got a question from Massimo Pagani. Is it possible to connect field devices working Profibus PA to the APL switch?
Yes, of course. That's the idea. And that's what I showed with this brownfield. So we have 2 versions. One has the proxy included. So there you are free. You could start with an Ethernet APL switch and could put 16 PA devices behind that, Profibus PA devices behind that. And then when you move into Ethernet APL, you can exchange these Profibus PA devices with native Ethernet APL devices. That would be the idea. I mean, I even talked to a customer. He said, okay, what he's going to do is he's going this way, and then he's taking, because I asked him, what do you do with the Profibus PA devices when you move on? They said, okay, I still have heaps of Profibus PA applications. So use that, put that in stock. So I don't throw that away. I put that in stock and use it as replacement elements, which I found a very smart way to handle that.
Question from Dimitro Suravel. What do I need for the development and testing of field devices?
Yeah, okay, that would be more a question to a field device manufacturer. I mean, from a switch perspective, not that much. I mean, the switch in this sense, if it's purely APL, that's a nice thing. It's only a layer 2 switch. You could even use an unmanaged switch to do that. All you do, you have to have access to your APL devices, field device, then you do the testing. So the switch itself wouldn't add a lot of stuff. to that. Probably would be a good question to Anderson Hauser or Vega or some others, or we can also follow up. I can get you in touch with our commodule APL experts because they do things like that in detail.
And another question by Jaap is, will the APL switch be ATEX dust certified for zone 21 and 22?
Yeah.
Fabrizio Corti, could you tell again the distance which can be covered? Trunk and spur.
Okay, it's two things. So for the existing technology, if you look at the north side, okay, do you see the picture? Ah, yeah, okay. Yeah. Okay, so actually to the north side, this one here is normal Ethernet connectivity. So to the north side, you have the 100 meters if you use copper, or you have 2 to 3 kilometers. A lot of people are using fiber channel for that. To the south, what's in the spec are 200 meters to each of these devices. And it's depending on the cable. So what we're doing in here, we are also checking what we think would be doable. We also had, it's funny because this number really sticks to my mind. We tested 607 meters. Don't ask me where the 7 meters come from. With the others are on a kind of a cable thing like that, and that worked with full speed. So it depends on the cable you are using, but the certification is actually up to 200 meters.
Again, I think we had the question earlier, but from Patrick Valasovic, does your field APL switch, is it X-rated? So X certification, basically.
Yeah, it's the ATEX. So it's zone 2, so it fulfills all the zone 2 requirements for ATEX. Perfect. I can also, I think we are sharing this slide deck anyway later on, because on one of the slides we have all the different ATEX specifics on it.
Okay. Got another question from Mohsen Habibi. What is the maximum number of channels the APL switch can support?
In this one, it's 16, because 16 slots, it's always point to point. With a 16 slot, that's one fixed. And the thing is also, we have some customers, because the way how it's built, it's in IP30. So we really want to make sure that there are no holes or whatever it is. So we have some industries where they really say, I want to have a higher IP level. That's one of the reasons why we said, okay, I want to have this on at least on an IP30 level to make sure that some dust doesn't go in.
Thank you. Another question by Massimo Pagani. Is it possible to interface field devices that work in 420 milliampere to an APL switch? If so, how does the interfacing occur?
Not really directly. We are looking at some possibilities how to do that. I mean, there are other. I mean, one would be like a way of like a remote I/O access, things like that. I got this request also from 1 or 2 customers who were looking at what the possibilities are, but that would be more than kind of a remote I/O setup, not directly.
Thank you so much. Have a good rest of the week.
Yeah, thanks to the audience.